In this video, I'm going to take you through a full tutorial on surds. So if today is your first time on this channel, kindly subscribe and hit on the notification bell so that anytime I upload the video, you are going to get a notification on your phone. And today we are going to deal with anything you need to know about surds. But before that, I've got you some objectives that at the end of the lesson you have to attain. One, at the end of the lesson, the student should be able to simplify surds. 2. Carry out operations involving sets. Now let's start with the definitions of sets. So let's take the positive square root of these numbers. 9, 25, and 81. So when we take the positive square root of 9, 25, and 81, we are going to get some exact values like 3, 5, and then 9. So these are numbers we call rational numbers. So what about the case that we are going to have root of 2, root of 3, root of 5? We're going to get something in decimal form. So these numbers, we call them irrational numbers, and their roots are known as surds. In general, every prime number is a surd. The root of every prime number is a surd. So let's move on to reduction of surds to its basic form. So we are coming to reduce surds to its basic forms. And now we say if the root of x is such that it cannot be reduced further, then it is said to be in its basic form. For example, when we are having root 5, root 2, root 3, root 6, these are said that we cannot simplify further. So we can say that they are in their basic forms. But for instance, let's take root 24. Root 24 is not in the basic form, so we have to change it from wherever it is to its basic form. But before we can change this to its basic form, let's take note of these perfect numbers. We are having 4, 9, 16, 25, 36, 49, 64, 81, and 100. There are more. You can search for the others. There are more. So before we can solve for this 24, or before we can reduce it to its basic form, what we are going to do is that we are going to pick one number from these perfect numbers and multiply it with a different number that is going to give us 24. So 4 times 6, we are going to get 24, meaning we can fix 4 times 6 over here, and it's true. 4 times 6. So 4, 6 is going to give us 24. So from here we can distribute the roots. So when we do that, we are going to get root 4 times root 6. And then root 4 gives us 2. But root 6, we cannot simplify any further, so it's still as root 6. So we are going to get 2 root 6. So this is in the basic form. So the basic form of 24 is 2 root 6. Now let's solve this question. I'm going to give out 2 questions. I'll solve one and you solve one, and let me see your answer in the comment section. Okay. Example. The first one is mine, which is 27, and the second one is yours, root 128. So with this one, we are going to pick out some number in the perfect numbers and then multiply it with a different number that is going to give us 27, and 9 times 3 give us 27. So root 27 is equal to root of 9 times 3, which we are going to get. Then we can distribute the roots. 9 times root 3, and then root 9 is 3, so I'm going to get 3 root 3. So try this and let me know your answer in the comment section. Now we are moving on to addition and subtraction of sets. So let me clean this. So we are moving on to addition and subtraction of sets. So before we can add or subtract a set, they must be the same or they must look alike. What do I mean by this? We can add A root P plus B root P. You can add this because they look alike. Root P, you can add them. So I'm going to get A plus B, then you take one of the roots, root P. And then we can also subtract A root P minus B root P, which we are going to get A minus B root P. But take note, root 3 minus root 2 is not equal to root 1. Never. It's not equal to that. Likewise, root 3 plus root 2 is not equal to root 5. But before you can add or subtract sets, check whether the set that you're about to add is in the basic form or not. If not, you convert it first before you add. Okay, let's solve some example. First one is this one too. I'm going to solve, it's 3 questions. I'm going to solve 2 and solve 1, and I will know your answer in the comment section. Okay, I'm having 5 root 2 plus 3 root 2. So this one, we are going to add 5 because they have root 2 and root 2 here, meaning they look alike. So we're going to add 5 and then 3 to get 8. And then we take one of the roots, root 2. And I'm having root 50 plus root 32 minus root 162. So if you look at the question, you can say we cannot add or subtract because they are not the same or they don't look alike. But you can add and subtract them. Just analyze it and you're going to realize that it is not in the basic form. So you have to convert it first. And if you do that, you are going to pick one number from the perfect numbers. So I can pick 25 times 2, I'll get 50. So I'm going to get 25 times 2, 50, plus 16 times 2, 32, plus 81 times 2. It's going to be 162. Now you can distribute the roots. I'm going to get root 25 times root 2 plus root 16 times root 2 plus root 81 times root 2. Now root 25 is 5, so 5 times 2, 5 root 2, plus root 16 is 4, 4 times root 2, I'm going to get 4 root 2, then root 81 is 9. Is it minus? Here is minus, minus 9 root 2. So from here, they look alike now. At first, there was nothing like that, but at the end, they look alike. So kindly know how to treat such questions when you meet them. So you are going to add 5, 4, and then minus 9. So 5 plus 4 minus 9, and you take one of the roots, root 2. So 5 plus 4 is 9, 9 minus 9 is 0 root 2, which is going to give us 0. And then solve this one by yourself and let me know your answer in the comment section. Which is I root 147 minus root 75 plus root 27. So kindly solve this and let me know your answer. Okay. So next we are moving on to properties of sets. So we are moving on to properties of sets. The first property is that when we're having root a times root a, root a times root a, we are going to get root a all squared, which is going to give us a. So this is one property. 2, root a squared is also going to give us a. So when we're having something like root 2 squared, I'm going to get 2. 3, root a times root b. Root a times root b is going to give us, this one we are going to multiply a by b, so ab. So for instance, when we are having root 2 times root 3, we are going to get 2 times 3 is 6, so root 6. 4, root a over root b, we are going to get the root of a over b. So when we have root 2 over root 3, we can write it as the square root of 2 over 3, which by the property is the same. And then let's move on to the fifth one. If we are having a root b multiplying root c, then we are going to get this a is going to multiply, is going to be there, and then what is in the bracket will multiply themselves, bc. So for instance, when we have 2 root 3 multiplying root 2, we are going to get 2 will be there, then 3 multiply 2, which is 6. So let's move on to the sixth one. A times root b. So a times root b, we are going to get a root b. For instance, when you're having 2 times root b, which is root 3, we are going to get 2 root 3. Then the seventh one, we're having a times root b times c times root d. So this one, a is going to multiply c, so you're going to get ac root bd. So for example, when we're having 2 root 3 times 3 root 2, we're going to get 2 times 3 is 6, root 3 times 2 is 6. Now let's move on to the last one, the last property. A times B with C. A times B with C. So this one, I'm just going to multiply A by B, AB with C. For instance, having 2 times 3 with 2. So 2 times 3, I'm going to get 6. 6 with 2. So that's all for the properties of sets. Now let's move on to multiplication of sets. How we are going to multiply sets in those stuffs. So we are moving on to multiplication of sets. So multiplication of sets. So when we are multiplying sets, all the properties of sets must be observed. So let's start with this question. An example writes root 3 minus 1 into 2 minus root 3. So this is more like you're having an expression like a plus b into b plus c. So I'm just going to pick the first one to multiply the whole bracket, and then pick the second one to multiply the whole bracket. So we are going to apply this knowledge to the question we are having over here. So when we pick the first one, it is root 3 multiplying the second bracket 2 minus root 3, and then you pick the second one minus 1 multiplying the second bracket 2 minus root 3. Root 3 times 2 is going to give us 2 root 3. Then root 3 times root 3 is going to give us 3 from the properties. Minus 1 times 2, I'm going to get minus 2. Minus 1 times minus root 3, I'm going to get plus root 3. Now, minus 3 minus 2 is minus 6. So you are going to get minus 5. Minus 5. And then we are having a set here and a set here, which they look alike. So you can add the coefficient here to this one, which is 3. So plus 3 root 3. You can also write as 3 root 3 minus 5. Either is correct. Now another question is, we are to simplify 1 minus root 3. 1 minus root 3 into 1 over 3 plus root 3, and give your answer in the form p plus q root 3. So can you solve this and let me know your answer in the comment section. Let me know the value for p and q. Now let's move on to rationalization of sets. So this is the process of making the denominator of a fractional set whole or rational numbers by multiplying both the numerator and the denominator by the denominator. Okay, let's consider this. This one will make you understand it's very clear. When we are having sets like 1 over root 2, to rationalize this, we are going to multiply the denominator by the numerator and the denominator as well. So we are going to get this times this is going to give us root 2 over root 2 times root 2 from the properties is 2. So this all about rationalization of numerator. I'm going to write two examples. You solve one and then I'll also solve the other. So these are the examples. I 2 over root 5 and I is root 2 over root 7. So solve this and I'm also solving this. So with this one, we are going to multiply the denominator rather, which is root 5 by the numerator and then the denominator. So we are going to get 2 root 5 by root 5 over root 5. So 2 times root 5, we are going to get 2 root 5 all over root 5 times root 5 is 5. And that will be all for our lesson on sets. Kindly subscribe and hit on the notification bell so that anytime we upload a video, you are going to get notification on your phone. Thank you for watching.